Lesson 8, Module 3. Why stay with whole numbers? The sequence of perfect squares 1, 4, 9, 16, 25 earned its name because the ancient Greeks realized these quantities could be arranged to form square shapes. They took 4 dots and they made them 2 by 2. 9 dots was 3 by 3. 4 dots 16 4 by 4. I'm just going to go ahead and write these numbers here so we can think about them. We've got 1, 4, 9, 16, and 25. I'm wondering if you can see the rule. If Sn denotes the nth square number, what is the formula for Sn? Did you write? Because if you did, you're right. Good job. All right. If you didn't, hopefully you can see that 4 is 2 squared, 3 squared, 4 squared. What do you think the S of 50 would be? And if you wrote, okay, 50 squared, and you got yourself 2500, you were right. Could we figure out what the S of 0 is? Prove whether or not 169 is a perfect square. Well, it doesn't take a whole lot of imagination. Let's see, 10 squared is 100. I'm just going to work my way up to it. 11 squared is 121. 12 squared is 144. And hopefully you're just sitting there going, Miss Love, come on. And 13 squared is 169. So it's a perfect square number because we see that 13 squared is 169. That means we could arrange dots 13 by 13. I'm not going to do that. To prove whether or not 200 is a perfect square number, well, I'm going to keep going. 14 squared is 196. 15 squared is 225. And what we see is that 200 lies somewhere in between, but it's neither one of those, which would create a square that was, we could get 14 by 14, and that would give us 196. Or we could get a little bigger and get 15 by 15. But as you can see, there's no number in between 14 and 15, so we can't get a number evenly distributed. So it says, if Sn is 225, then what is n? Well, I think we can see that we're looking right at the answer. It's right here. 225 is 15 squared, so n is 15. This is student page 44. Which term is the number 400 in the sequence of perfect squares? How do you know? Well, I'm hoping that most of you can see that 400 is the same as 20 times 20, and that tells us that it is the 20th term. Create dots into squares. Suppose we extend our thinking to consider squares of the length centimeters. Create a formula for the area AX centimeters squared if the square of the side length is X centimeters. So our formula would be something very simple. It would be X squared centimeters squared, because we're actually now taking those centimeters and turning them into squares, little squares, a square centimeter. And we're counting how many of those we see. Use the formula to determine the area of a square with a length side 3, 10.5, and pi. So all we want to know is area of 3, and we're going to put that into our formula, 3 squared centimeters squared. We want to know the area of 10.5, which would be 10.5 squared centimeters squared. And we want to know the area of pi, which would be pi squared centimeters squared. All right, hopefully you can see the answer to this guy is going to be, we're just going to do the part of the math we can, 9 centimeters squared. This one, 10.5. When we square 10.5, we get 110.25, and that's cm squared. And here, pi is a number that's best left pi. And so we're going to say that this is pi squared centimeters squared. We're going to leave it at that because it's the easiest way to look at it. What does the area of 0 mean? Well, it means, what is the area of a square whose side length is 0? Hopefully it's obvious to you that the area of a square whose side length is 0 is 0 squared centimeters squared, and that makes it 0 centimeters squared. No big deal. Okay, now these are a little more complicated. Since this is an area formula, we can't have we don't have distance that's negative. So for this one, it's a hypothetical situation, but there is no answer for it. This one, however, there is a possibility. What is the area of a square whose side is the square root of 2? And so we're going to go ahead and we're going to think about square root of 2 squared, and those are centimeters squared. And I'm going to go ahead and draw you a quick picture of this. Just let's have a quick sketch. We've got a square. Okay, it's not a square, but it's supposed to be, whose side length is the square root of 2 and the square root of 2. Now, if you don't know, I want you to put it in your calculator. What is the square root of 2 times the square root of 2? And hopefully you got 2. So the answer is 2 centimeters squared. So any root times itself, basically a square cancels a square root, which is kind of nice.